In this video I'm going to expand upon the principles that I did in the previous video on solving equations graphically, and I'm going to show you how we can use graph techniques to solve quadratic equations. In the last video I solved a linear equation, and this video is going to be now dealing with quadratic equations. So for example, I might need to solve x squared is equal to 3x plus 4. I might need to solve that quadratic equation. The principle behind it is exactly the same as the principle about solving linear equations, so I'm not going to explain the rationale behind it. I'm just going to say this is what I would do to get the accurate answer from a graph. First of all, the left hand side is x squared, so first of all I would say let us plot a curve y equals x squared. Well, I know what that looks like, so I can do a sketch of this to demonstrate what you'd need to do. Now obviously you would be setting up a table of values, you'd be plotting the points accurately on an accurate scale, and you'd get a perfect U shape, something like this, in that sort of position. So that's y equals x squared. The second graph, you take the algebra on the right hand side of the equation, which is y equals 3x plus 4. You set up a table of values for it, you work out some points to plot, you plot them, and you will get a straight line because it's a linear plot. So I know from our basic sketching work that plus 4 on the end means it would cross at 4, something like that. I know that 3 in front of the x means a slope of positive 3, and so it would look something like that. So that is y equals 3x plus 4, and the original curve is y equals x squared. Notice that we get an intersection of the two graphs again, like in the previous video on linear equations and linear graphs. But this time, notice that there are two intersection points because we have this U-shaped curve which cuts the straight line in two places. Well, that shouldn't be a great surprise, because if you think about it, if you were to solve a quadratic equation by algebra techniques, it would give you two solutions. It's a power 2 equation, you will have two solutions. So we see two intersection points. To find out what the x values are, which are the solutions to that equation, this is the mechanical process. I'm not explaining the rationale here, just the mechanical process. You simply drop down vertical lines to your x-axis and read off the two x values on that x-axis, and they will be the two solutions to the quadratic equation. And if you do your graphs really accurately, it doesn't matter if those are decimal values, because you can still use an accurate graph to get decimal values to 1 or even 2 decimal places depending on the question. A really useful tool. So let's have a look at another one. If I decide to solve something like this now, so if I was to do x squared plus 7x plus 12, and I said equals 0, something like that, okay, and I said I solve that graphically, what would I do? Well, I'd have to plot two graphs. I would have to plot, first of all, y equals x squared plus 7x plus 12, and I'd have to plot y equals, now on this occasion I've just got a 0 on the right hand side, so I need to plot y equals 0. Okay, now the first one obviously is not a very nice equation. It's a quadratic curve, but it's quite awkward to work out because it's got x squared, x's, as well as a number on the end. So what you'd have to do is set up a table of values, work it through carefully, get 5, 6, 7, 8, 9 points to plot, and then plot them very carefully to get some sort of U shape. We know it's a U shape because it's an x squared graph. Okay, so if I was to do this, I am just going to sketch for you the basic principle of what we would be having going on. What you'd find is you get a picture looking something like this. Those two are 2 points that I know because I'm familiar with what the curve looks like. And the curve would look something like that if you plotted it accurately. Okay, that value there would be -4, and that value there would be -3. I'm just telling you, if you did this accurately with a table of values, that's what you would get. Okay, so the picture looks something like that. Okay, so there's the curve plotted. Y equals x squared plus 7x plus 12. Let's imagine you've done that from a table of values. Next, you would plot the graph of y equals 0. Well, y equals 0 is just a straight line. Remember how this works. If it's y equals a number, you just get a horizontal line at that y value. So if y equals 0, I'll change colours for this. Y equals 0, you go to 0 on the y-axis, which is there, and you just draw a horizontal line. So y equals 0, remember, is just the x-axis. So I'm going to extend this in red right the way across. Here, use a ruler obviously, and that is y equals 0. So I've got two graphs drawn. I've got the original curve, which you got from a table of values. I'm just showing you what it would look like if you did it accurately. And you've got the line y equals 0. What we do now is see where those two graphs intersect, and at those intersection points work out what the x coordinates are of those 2 points. Well, you can see here that they actually intersect there and there. And because y equals 0 is the x-axis, you don't need to drop any dotted lines down or in fact any dotted lines up to get to the x-axis. They actually lie on the x-axis itself because the red line was y equals 0, x-axis. So all I've got to do is read off what those two values are, where the curve crosses the line y equals 0. And they are -3 and -4. Once again, remember, I'm telling you they're -3 and -4. This is not an accurate plot. I'm saying this is what you would get if you plotted it. So the answer to the equation would be, therefore, x would be -3 or x equals -4. And they would be the answers you would get if you did this accurately, and they would be the answers you would get if you solved that by algebraic techniques. So there you go, we've got a very straightforward quadratic equation being solved by graphical techniques. And that's the end of this short video.